Hi, I'm Kyle Castillo, and for my experiment, I'll be trying to determine the solid vapor surface tension using various liquids on a solid surface and Neumann's equation of state. So up here we have the Neumann's equation of state. For a given solid surface, it shows that the relationship between the liquid surface tension and the contact angle can be plotted to form a smooth exponential curve. So for my experiment, I'll try to apply various liquids on the same solid surface and measure their contact angles, to which I will then plot against liquid surface tensions and use the trend line to calculate the surface tension of the solid surface. So I'll be testing these various liquids I found around my house, and I will be applying it to Teflon tape as a solid surface. So I take a strip of my Teflon tape and smoothen it on a flat surface. And for each liquid, I'll try to pour a very small drop onto the surface, which I will then take a picture of and measure the contact angle from. And here are the contact angles for all of my liquids. Also, I searched up for each liquid's surface tension at room temperature, and with that information, I am able to make my plot. Here I take my data and make the plot with the x-axis being the liquid surface tension and my y-axis is the cosine of the contact angle plus 1. And with Microsoft Excel, I was able to make an exponential trend line out of my data. But as you can see with my data points alone, they don't follow the smooth exponential trend line very well, but I'll still persist with my calculations. With my obtained trendline, I have this least square fit equation, which I can then relate to Neumann's equation in order to solve the solid vapor surface tension. So in evaluating the least square fit equation at some points, I can then use a numerical method to solve the constant unknown terms in the Neumann equation. And so I find my surface tension of my Teflon tape to be about 45.4 millinewtons per meters. And I can also determine my beta constant. But before ending, I should address some of the flaws of my experiment. For one, I compared my observed result to the tabulated surface tension value of Teflon. I found that my observed value has a significant difference from the tabulated values, which can range from 14 to 28 millinewtons per meters. This was somewhat expected given the low accuracy of my data points, and my R-square value of 75% shows that I had significant error. But there are some explanation for the significant error in my measurements. As discussed in class, contact angles are not something that can be easily measured, and I had to measure 7 of them, so that may have contributed to that problem. And there could have been some technical errors I didn't notice at the time, such as making the size of my droplets inconsistent between liquids. On that matter, the assumed surface tension for liquids I searched online may not have actually represented the liquids I actually used. And there could be many more explanations, but for now, that's all. Thank you.